All right, welcome out to Wireshark 101. I'm Kyle Fates. I skipped past my intro slides so that you could be downloading the files if you want. This is not a training, but it's sort of set up like a training in terms of we'll be doing stuff, and you're welcome to follow along. Since it's not a training, I won't be down walking around, and we won't like stop for 10 minutes as we're working on things. It'll be more demo, but you'll benefit more if you follow along, I think. So go ahead, and if you haven't already, download Wireshark, download some capture files that I'll be walking through. Again, you don't have to, but that's kind of how I'll be doing this presentation. So I've been coming to SAINTCON for several years now. I've been doing presentations on Wireshark for several years now. I teach up at Weber State University. We have an entire class on Wireshark, and you get 1 hour's worth of it. So we're just barely scratching the surface of what you can do. That's part of this skills needed versus skills covered. You're not going to walk out of this presentation a Wireshark expert, but hopefully you'll at least walk out knowing what Wireshark is and how you might be able to apply it into your field and some of the cool things you can do with it, and give you a starting point. This really is meant to be at the introductory level, so if you've been using Wireshark for years, you probably won't get much out of this presentation, although who knows, there's always little things I find as I talk to different people of different ways of doing things, so you may pick up on some small nugget or whatever. If you're sitting in the very back, you might not be able to see the Wireshark demo stuff because the text isn't that large. I did bump up the size, the default size in my Wireshark instance, but we still got to be able to see all the stuff, so I didn't bump it up too much. Anyways, you might want to move up front if you want to see, I guess is what I'm saying. Wireshark, it lets you listen to what's on your network, right? It shows you the actual packets flowing across your network. So with that, you've got to be aware that there are like legal ramifications to listening on people's networks. And so if you're using Wireshark to do live captures, just be aware of that, right? Like know what the law is, know what company policy is, know if you're allowed to be sniffing traffic on that network or not. So that get that disclaimer out of the way. You can't come back and say, oh, well, I was at SAINTCON and Dr. Fates told me I could sniff anything I wanted. No, I'm not giving you permission to do that, but sniff what you're allowed to. How's that? Okay, let's talk a little bit about Wireshark. If you haven't downloaded it, hopefully get it downloaded. I just opened up the baseline PCAP file from the samples here, and we just want to do a quick tour of the interface. It's, we'll skip kind of the basics. Here's all your menus, right? Just like every other program has menus. But the thing you care about is these three areas. So this top area on mine, it's your packet list. It's the list of all the packets that Wireshark has captured, or in this case, right, it's a pre-captured file. It's the list of all the packets that were captured at the time that we took the capture. On the left here on mine is, oh, thank you. By the way, yes, when I'm not showing you, you're like, what the heck's going on? Shout it out. If you have questions, shout it out. Like I said, this isn't a training per se, but it is a little bit interactive. If you've got questions about what I'm doing, shout them out. So let's get this over where you can see it. Which way do I gotta go? This way. There you go. How's that? So here, this top section is the packet list. This bottom left section is the packet details. And then this bottom right section is the actual bytes of that packet. And I'm going to switch my view here. This is not working. We're going to switch this to duplicate. Okay, now I can see what you guys can see. I don't like this default view of Wireshark. I prefer them listed 1, 2, 3 from top to bottom, so I'm going to switch it that way. That way I can make better real estate of my wider screen and still see all the packet bytes now. Okay. This little bar right here up top, I told you if you're sitting in the back, you won't be able to see. It's in between the buttons and the packet list. There's like a little filter bar. That is key to using Wireshark. It lets you filter your giant list of packets down to the packets that you actually care about. So in this capture file, if you look down at the bottom right under the status bar, it tells us there's like 30,000 packets in this capture file. That's a lot of packets to look through when we're looking for something specific. And so if we want to only look at packets that are using SSH protocol, for example, we can apply a filter and say, hey, let's get rid of those 30,000. Let's filter it down to the ones that deal specifically with SSH. And so in this case, right now we're only looking at 1,242 packets. So we've, what was that, 4%? 4% of our entire thing. It gives us a much better view of what it is that's going on. And we'll talk more about the filter in a little bit. Okay, we covered all those areas. The filter bar, packet list, packet details, status bar. Let's talk a little bit about how you actually capture the traffic. It depends on what kind of network you're sniffing on, how you're going to go about doing that. Lots of times your router or your switch will have the ability to capture packets directly. Sometimes they'll have the ability to turn on what's called port mirroring or port forwarding, where you can forward all the traffic that the switch receives out a specific port on that switch to then capture from like your laptop or whatever. Sometimes you'll put a tap in line, here's your network connection, your Ethernet cable or whatever, and you literally unplug it, plug it into your tap, right, plug another cable in, plug it back in so that you're in line of what's sniffing. I have a little network tap that I was going to bring to show you. It's in my hotel, I forgot. So those can be useful. If you're capturing wirelessly, you can capture your traffic from your Wi-Fi signal and pick up what's on the wireless network. Back when wireless networks were open, that was awesome because you could see everything that everyone was sending. Now that most wireless networks are protected, it's not quite as awesome. You can't see quite as much, but you can still get some good traffic that way. So we only have an hour. We don't have time to go over all the details, but I do want to point out something here is you're not going to see traffic that your network doesn't see. Right? You can only capture traffic at the point where you're capturing that it's going to see. So if you want to capture traffic between N12 here and N9, and you've got your sniffer hooked up on N4, that's not going to work. The traffic's not flowing along that path, right? It's flowing between N12, N5, N8, N7, and N9. Right? N4 is not in that path, so you wouldn't see that traffic. Okay, so that's something to keep in mind. You're only going to see the traffic along the path that you're sniffing on. First step in doing a good packet analysis is to know what you're looking at, know what is expected on your network. I told you I teach a class up at Weber State. One of the things I have people do is I have them, capture some traffic on their own network if they have a network that they control. If not, we set up some VMs for them and stuff. But almost every time, they go down these little rabbit holes of like, oh, what? I found some malicious traffic on my network. when actually it was just their Roku, right, sending out a broadcast to find the other devices on the network. So first step is take this baseline, know what normal looks like on your network, right, so that then you can find the traffic that's not normal, or find the traffic that you're looking for. I better back up for 1 second here. A couple things that you can use Wireshark for. You can use it for finding malicious traffic, right? You can use it for troubleshooting problems, like you're trying to connect to your printer and it's not working. Why not? Well, let's look at the actual packets on the network and see what the network sees, right? So that's, I use Wireshark more than anything for troubleshooting. Anytime something's going wrong on my network, a device isn't talking to another device, rather than like try and figure out by running 10 different tools and first pinging it and then seeing if I can connect over network. Right? Let's just drop right into Wireshark and see what's actually happening on the network. So you can use it for that kind of stuff. You can use it for troubleshooting. You can use it for doing like malware analysis and monitoring what kind of communication your malware's doing. Put it in a sandbox environment and see what kinds of servers it tries to reach out to. Okay, so that's some of the things you might be doing with Wireshark. But for all of those, you want to know what normal looks like. You want to know what you're looking for and what's different than what you're looking for. Wireshark has a whole bunch of statistics that you can look at to help you understand what's normal for your network. So you can look at statistics like how much HTTP traffic is in this capture file, how much SSH traffic is in this capture file, how many endpoints are involved in communication in this capture file, right? And so again, in an hour, we don't have time to go over all the different statistics, but let me highlight a few of the different ones that are kind of beneficial here. So conversations and endpoints are both similar. Let's pull up, we'll start with conversations here. Conversations can be done at different levels of your network. So you can talk about conversations between MAC addresses, right, at our layer 2 communication. We can talk about conversations between IP addresses, layer 3 communication, right? We could talk about conversations at our TCP or UDP layer 4, right, the transport layer. And so in our conversation tab here, we have different tabs for those different levels of our network. We can see in this capture file and limited to the display filter, I don't know if you can see that over on the left, it's the checkbox. I still have the SSH filter applied. So I'm only seeing conversations that are tied around this SSH protocol, right? Because I'm limited to this display filter. And with that, I see 3 different conversations going on at my layer 2, 3 different conversations, layer 3, right? These same 3 IP addresses are tied directly to 3 MAC addresses. But then TCP, I see 62 different conversations, right? Because there's multiple SSH connections happening between these devices over the life of this capture file. And so you can get all kinds of statistics about this conversation, like how many packets total are in the conversation, how many are being sent, how many are being received in each direction, all right? How long was this conversation? So most of these are very short. The longest one is a second. Is that really true? That's what it's showing me. Must be true. For this baseline, we're calling that normal. If this was on my actual network and I saw a whole bunch of SSH connections that were only lasting for a couple seconds, I would think that's probably not normal, right? Most of the time, you're not just SSHing into a connection and immediately dropping that connection. You're doing stuff with it. You're running commands, and that's going to take more than a second. So this view, right, can help you understand a little bit the broad picture of what you're seeing with your captured traffic. If I uncheck the box, so now it's not limited to the display filter. Now I've got 517 different TCP conversations because I'm including all the other traffic that was in this capture file, the HTTP traffic. I don't know what else we've got in here. We've probably got some DNS traffic in here, right? So now we're seeing some conversations happening over UDP, whereas when we limited it to just SSH, we weren't seeing any UDP traffic because SSH doesn't use our UDP protocol. Okay? Close this one. I told you endpoints is very similar. When we pull it up, you'll see it looks very similar. Same type of thing. You can limit the display filter or not over here. You've got your different tabs showing different layers of the network and addresses at those different layers. But now, instead of showing pairs of endpoints, pairs of devices communicating, now it's just the individual endpoints that were involved in that communication. So whereas before we had 3 different pairs, now we see there's 4 different devices, right, involved in those connections. Same thing with TCP. Now it's 63 different endpoints, which would be an IP address and port number combined to make our TCP endpoint. And again, we get statistics on those. Okay, we're going to skip most of these other statistics for now. You can look into them. There's specific stats for HTTP, DNS, right? There's other stats showing your throughput rates and stuff. And so this is, again, like your springboard, your jumping off point, giving you a starting place to look at, and then you can take it further as you in the direction that you need for your work or your personal enjoyment, whatever you're doing with it. Another thing to keep in mind when you're defining what normal is on your network is normal changes over time, right? As you add new devices, they change the communication patterns you see on your network. So before you had a Roku, you didn't see any of those broadcasts from the Roku saying, hey, look, here's me, come connect. Once you add the Roku, you start seeing those. And that's going to change what normal looks like on your network. So don't think, oh, I looked at my network 10 years ago. I know what the traffic looks like on it. It's probably significantly different now than it was 10 years ago, and maybe even significantly different than it was a year ago, depending on how your network has changed in that time. Let's look at, just deciding on time, we kind of looked some at the baseline, and I think we'll call that good enough for now, because I want to talk about some of the more interesting stuff. Okay, so you want to capture traffic. The problem is now almost everything's encrypted. I told you already with wireless, it used to be awesome because the wireless networks were open and you could just sniff everyone's traffic. And now it's even worse because not only is the network traffic encrypted like wireless, but all the application layer traffic's encrypted. Everyone's using SSL, everyone's using TLS, which is great from a security standpoint, which is awful from a I want to see what's going on my network standpoint, right? Because it's all hidden from you. You got it's all encrypted. Like, hey, how am I supposed to know if I'm talking to my printer when it's encrypted? Good news is we can solve that in a lot of ways. And back to Wireshark here to take a look. So Wireshark provides several built-in ways to decrypt your traffic. Now, it can't do it magically. It has to have the keys to do that. So you have to have the keys to do that in some way. But let's talk about how you might go about doing that. So in your edit menu under preferences, under protocols, well, yeah, we'll go this way first. So under protocols, and you scroll all the way down to the TLS protocol. There we go. I'm not very good with the alphabet, but we found it eventually. On the TLS protocol, there's some options to set the RSA keys. So if you have the private RSA key that was used, you can point it to the file, and it will then use that in decrypting your traffic. If you have the pre-shared key that was used, you can drop that in there, and it can use it to decrypt the traffic. Those two are great. We're not going to demo those two today. We're going to demo this pre-master secret log file name, because again, the way I use Wireshark the most is troubleshooting stuff on my network, and so this is probably the most approachable way to decrypt traffic in that scenario, which is you have the decrypted traffic, right? You're on the endpoint device that's able to show you your bank account information or whatever. You're logging into your bank, right? It's all encrypted from the bank to your device, but then when it displays on your web page, it's not displaying it encrypted, it's decrypted, right? The browser knows how to decrypt it and is able to display it to you in a decrypted format. So you have the information, your device has the information, you just got to get that information to Wireshark so it can do the same thing. Most network tools, your browsers, curl, I think wget, they all support a environment variable that says save these pre-master secrets to a file, which are what you need to decrypt the traffic. And so you set that environment variable, and you set it to a path of the file where you want to save it, and then every time you're browsing encrypted traffic, whatever tool you're using, whether it's your browser or curl or whatever, it will write these secrets to this file. And you can give this file to Wireshark, and Wireshark will then know how to decrypt your traffic. Okay? Kind of cool, right? Let's take a look at actually doing this. But before we do it, we got to load an encrypted file and prove that this actually works. So I'm going to switch to, let's do this SSL Weber capture file. So this is a capture file I made by just browsing to Weber's website, which was using HTTPS. And we should be able to see some of that, right? So here we're getting a whole bunch of TLS traffic, and more TLS, and more TLS, and more TLS. We can use a filter, right? And say, here, look at all this TLS traffic. So I've got 1,000 packets of TLS traffic. And when I click on one of these packets, a lot of them, let's adjust my columns. Instead of showing me the actual HTTP data, it just says application data, because it's all encrypted. It doesn't know what it is. And so when I click on, I'm on, for example, packet 245 here, and I expand out the packet details, I can see, oh yeah, it's using Ethernet. Here's the source and destination IP addresses. If I want to see all the details of that IP header, I can expand that out and see all those details. I can expand out the details of the TCP header. I see port numbers. I can see the sequence and acknowledgement numbers, all that good stuff. But then when I want to see the real good stuff, the data, right? Instead, I see the TLS layer, and I just see encrypted TLS data. And when I click on that, right, here's the bytes of that data, and it doesn't make any sense. It's nothing that I can just read and be like, oh yeah, that's the web page that I'm browsing, because it's encrypted. But when I made this capture file, I set the environment variable, which, by the way, did I put that in the... Yeah, I've got it in the side. This is the environment variable that you want to set. SSL key log file. Set it to a location, a file path, right? And then it will start saving your pre-shared master secrets to this file. And that's what I did when I browsed to Weber here. And we can now tell Wireshark to use that file back here where we were in our preferences. Protocols, TLS. Getting close. There it is. So right here, our pre-master secret log file, we're just going to browse to the SSL Weber key file. This is the file that the browser, right, wrote all those secrets to as I was browsing around to those web pages. I say, yeah, use that. Hit OK. It refreshes. And now, all of a sudden, instead of packet 245 saying, here's some TLS application data, it says, hey, here's some HTTP data. And we can see that it was a GET request to whatever this page is, count 2730EE, right? And we can see the OK response back. And make sure we're on that packet. Now, when I go back to my packet list, after my TLS layer, I've got my HTTP details, right? And I see the HTTP request with all of its headers, right? And I see, switch to this one, I see the response with all of its headers and the actual data of that response, right? Which in this case isn't much. We can also, under our bytes view, if I come back here and back here, under my TLS, when I'm looking at the application data, it's still garbage, right? It's still encrypted. But if I switch down here, there's a tab. Right now I'm on the raw frame. I can switch to the decrypted TLS. And now it's gone ahead and done the decryption on these bytes and is showing me the actual decrypted data. And I can see it, right, in plain text view, either as hex values or ASCII values over here. Okay? We've kind of thrown a whole bunch at you so far. You keeping up? You have questions? How we doing? Okay, sweet. I got some nods and some thumbs up. No one shouted out any questions. There's another capture file in there. If you want to try again the same thing using the SAINTCON capture file, same process, right? Just so you can kind of practice and walk through it, try things multiple times. So let's talk about types of things we might do to find what we're looking for. I've skipped over an important step of Wireshark because we've just been using pre-captured files. But if you're going to capture traffic, you have to tell Wireshark what interface to capture on and which packets it should actually capture, because you might not want all of them. So let's do that by, I'm going to close this file, and that'll switch me back to when you started Wireshark. You might have gotten this screen instead. This shows your recent captures, and down here is the different interfaces that you can capture traffic on. So I can capture traffic just to my WSL instance, for example, because I've got an interface for that. I can capture the traffic from my Wi-Fi, right? Here's all my different network interfaces that I can capture on. And notice right here in the middle, again, if you're in the back, you won't be able to see very good, there's a little place for a capture filter. And so this lets you, similar to how you apply your display filters like we saw before with like, oh, I just want SSH traffic to be displayed. You can do something similar with capture filters and say, oh, I only want to capture traffic from this IP address, for example. I only want to capture SSH traffic. I hardly ever use capture filters. Let me tell you why. Capture filters limit what is captured. After it's been filtered, you don't get it back in Wireshark, right? Because it didn't get captured. A display filter just limits what's shown to you, but it's all still there. So if you're like, oh, I don't think I need this traffic, I'm going to filter it out, do it with the display filter, because if you find out later you actually do need it, you can still go back and get it. But if you filter it out at the capturing level, right, it's gone as far as Wireshark's concerned. Right? It can't go back and get something that it didn't save. So I hardly ever use capture filters. Though there's a couple times that I do. If I want to capture a specific traffic, like I'm on a network that is either a sensitive network or a network that I don't control, or right, something along those lines, and I want to make sure that I'm respecting the privacy of other devices on that network, I might say, oh, only capture a traffic that's specifically to my IP address, for example. And that way I don't pick up anyone else's traffic accidentally. Okay, so that's a place where I use capture filters. Sometimes I'll use capture filters if I'm capturing on my local device and connecting remotely to the device that I want to capture traffic to. And so I'm getting that stream, like my SSH connection to the device I'm connecting to, and I'm capturing traffic on that device. I don't want to generate more traffic by sending the traffic back to my capture device. And so I'll filter that traffic out specifically. So there are use cases where a capture filter is beneficial, but I just remind you or warn you again that when you capture traffic and you apply a filter, that traffic doesn't get saved. And so if you go back and say, oh, I actually need traffic from this IP address, or I actually need UDP traffic, I thought I only needed TCP traffic, you can't get it back if you apply it with a capture filter. You can go back and look at it if you just use display filters. Okay? It has a bunch of built-in filters that give you sort of a starting point in the bookmarks, like, oh, I want to filter by this Ethernet address, or I want to filter to only IP traffic, or to this specific IP address. Right, so that gives you sort of a starting place of types of capture filters you can build. And then they also have, right, you can manage capture filters. These are the ones that are saved, and they should have, if we, oh, that's not the one I want. Okay, let's delete that. We'll look at this when we're looking at display filters, because I don't know that Wireshark has it for capture filters. They have a display filter build tool, right? So you don't have to know, for example, that Wireshark knows that it's called SSH and then not some other name, right? How do you know what name to apply to the filter? You can use Wireshark's build tool, filtering tool to provide you those. So let's open this back up. Last three. Oh, this little. So this is if you want to apply additional settings on those interfaces. So these are different interfaces, right, for capturing USB traffic instead of network traffic, capturing remotely over SSH. And so you can configure how that capture works. And that's what that little gears icon is for, is to set those settings for capturing on that interface. Good question. Okay. So I'm going to pull back up the baseline capture file just so we have something to work with. And clear out that display filter. We want, not that one. It's also not the one. I usually don't use this anymore, so let's see where it's at, though. Okay, I don't want to spend a lot of time looking for this. We'll find it as we're going through these display filters, or we'll probably find it. So we talked about with display filters, right? You can filter by protocols. So you can say like SSH, for example. A caution here is the way that this filter works is not by looking at all of the details of the packet and saying, oh, this matches an SSH pattern. It works by looking at the port number of that protocol, right? And so it's saying, when you say SSH, it's going to say, okay, I'll limit it to all port 22 traffic. Right? So it's not doing like an in-depth analysis to figure out what the SSH traffic is. It's just looking at port numbers and filtering from that. So if someone's running an SSH server on a non-standard port and you filter using this SSH filter, it won't pull it up in that filter, right? Well, what if you want it to pull it up? How can you do that? We can come here into our preferences again. And under our protocols, we find the protocol that we're interested in, so SSH, for example. And here, under TCP ports, you can specify which ports it should consider as SSH traffic. So it's already got 22 on the list, and I don't remember if this is a default or if this is one I've added. It's got 29,418 in my list. You guys can tell me if it has it in your list or not. It is in your list? Perfect. So it's already in there. And you're like, oh, well, maybe I'm running one on 2222, right? 2,222. So you just add it to the list. Click OK. It will reapply the filter. And now if we had any, which I don't think this capture file has any, yeah, our number didn't change, it would also be pulling in traffic with the port set to 2222, okay? So that's something to keep in mind that is easy to not realize when you just type in SSH and you think, oh, I'm getting all the SSH traffic. No, you're actually getting all the traffic with the port number specified in that protocol's preferences, okay? And so every protocol, or almost every protocol, has that same type of option to say which port to use for filtering that protocol or for detecting that protocol, okay? If you have filters that you use a lot, you can save those filters, just like we could with our capture filter. So you click the little bookmark over here. If you already have it typed in, you can just hit save the filter and it'll add it to the list. If you don't have anything typed in, save the filter will be grayed out, but you can still then do this manage display filters. Right? And here's all those filters that were in the list. You can add it, give it a name, like SSH, whatever. And then over here on the right is where you put in the filter that you're saving, right? Hit OK, and now it's added it to my bookmarks, okay? Under preferences, we have this filter buttons. You can also get to filter buttons over here with the little tiny plus next to the display filter bar. And so this is another way to kind of save filters that you use regularly. So you click the little plus and it just lets you enter it directly, or you go into preferences and it lets you enter them there. And same thing, you give it a name, like what do you want the button to be called? Oh, let's call it SSH, filter SSH. I don't need a comment. okay, and it just adds a little tiny button over there next to that plus sign. So now you don't even have to go through the list of your bookmarks. You can just click the button and it applies the filter. Now, with a simple filter like SSH, that's not that useful. You can type 3 letters and hit enter as fast as you can go up and click the button. But with a complex filter like SSH with the IP address of this and the destination of that, right, you can build these complex filters that then having it saved can be very useful. So let's just make this a little bit more complex to demonstrate here. So again, I can make the display larger. I can't make the menu and the display filter larger. So if you can't see, I apologize. That's as large as Wireshark makes it. SSH, 2 ampersands for and, IP.adder equals 192.168.3.1. Right? And now we're limiting it to SSH traffic that has this specific value for this specific field. This is one of the most powerful things about filtering with Wireshark, is you can filter on literally any field in any protocol you want, okay? So, I'm filtering on the IP address, but I'm not limited to that. I can filter on, specific values in my in any of these headers. I can filter for packets that have the sequence number in our TCP set to 1. And what I like to do is, rather than trying to figure out what it's named and if it's TCP dot this dot that, like figuring out the full path, is if I can find a packet that has an example of what I want to filter, then it's really easy to just tell Wireshark, hey, turn this into a filter. And you do it, right, by just finding that value you want to filter on, right-click on it, and then it has these either apply as filter or prepare as filter. The difference, apply applies it right away. Prepare just puts it into your filter bar but doesn't actually apply it, right? You haven't hit enter yet, basically. And you can choose how it should be applied, overwrite whatever the current filter is and just use this. That's what selected does, right? Not selected would be the same but opposite. Overwrite whatever's there and use and filter on everything that's not this. And then you can take what's there and just add an and to it, right? Take what's there, add a or to it, okay? So we'll just add a and, for example, right? And so now it automatically built that for me. I didn't have to type in the values to do that filter. It figured out, oh, he's filtering on tcp.sequence, seq, right, equal to 1. And it took care of putting that in there for me. So that's how I like to build filters rather than try and type it all out, is if I can find what I want to filter in a packet and then just apply it as a filter. Perfect, thank you. Yeah, right there. Analyze, display filter expression. So this is the builder I was talking about, or the wizard, right, is another way. If you don't know the names of things and what it's under and what subfield it's under and stuff, you can find it here. You can search from here. So you're like, oh, I don't know exactly where it is, but I know I want to filter, right, on using IGMP. Put that in the search, and it's like, oh, here's all the fields that are somehow related to IGMP. And then you can expand that out. Oh, yeah, here's what I want to filter on is this particular thing, right? And I want to say, okay, filter on that value if it's present, if it's equal, right? Here's all the different things you can do. Let's choose one like TLS. And let's filter for the handshake. Okay, and so TLS handshake itself isn't a value you can check for, and it's smart enough to know that and says, oh, all you can do is say, is this a TLS handshake, right? And so it doesn't have a equal or greater than or less than. But if we say, oh, let's filter for a specific certification type of TLS handshake, right? Then we can do that, and we can say, oh, let's filter for all of the TLS handshakes that are equal to X.509, right? And so it gives you the tools where you don't have to remember the exact syntax and stuff. You can build it out here. And down below, as I clicked on those different things in this green box, it's building out the actual filter to apply there. If it's green, that means it's good. It's a filter that Wireshark recognizes as valid. If you haven't selected all of the values yet, let's see if we can make it be not green here. Switch. Oh, it's too smart. It has all these pre-selected. If you're typing in a filter, here, maybe can we type? Nope. Down here, we start typing in a filter. When it's not finished, Wireshark's like, wait a minute, there's a syntax error here in your filter. It displays it in red. Right? You haven't finished that filter. If you try and apply it, it won't work. Right? Sometimes you can get it to turn yellow. I'm trying to remember an example of that, and I don't have one on the top of my head, but yellow basically means you put something in there that Wireshark thinks you might not have meant to, meaning it's a valid filter, but it is likely not filtering the thing you think it is filtering. Right? And so yellow doesn't mean it's wrong, but it means it's probably wrong. Right? There's very few times where I've encountered a yellow filter that it was actually what I wanted to filter. Usually Wireshark was right, and they were warning me, and they're like, hey, that's not doing the thing you think it's doing. Coloring rules. Let's talk about coloring rules for a second. So filters, super powerful. They're going to limit what you see down to just whatever you filter. Sometimes, though, you want to see more, but you want certain things to stand out in what you're looking at. Right? So you still want kind of the big picture of what's going on, but as you're looking at that big picture, you want to be able to pick out specific details of that big picture. That's where coloring rules come into play. Okay? So coloring rules, they look just like display filters. They use the exact same syntax as display filters. Anything that you can put in a coloring rule, you can put in a display filter, or vice versa. Oh, look, I'm not even sure how I scrolled here or what scrolled here, but here's some pre-existing coloring rules, right? You might have noticed already as you're scrolling through the list of packets, some of them are colored differently than other lists. Here's some bright red ones. Why are they bright red? Well, they're bright red because there's a coloring rule that Wireshark's applying, probably because it has this reset flag set on the TCP protocol. So it helps things stand out. And let's go into on our view menu, under our coloring rules. And this is where you can set those coloring rules. Wireshark applies them in order from top to bottom. The first coloring rule that matches is the one that gets applied, and then it quits looking through the rest of the list. So keep that in mind if you're creating coloring rules, is which one should have priority, because as soon as one of them matches a packet, the rest of them get ignored. So it's got default coloring rules to, highlight in red these reset packets for TCP, highlight in black packets where it's got TCP issues, like the window size is closed, or it detects missing packets that have to be resent, right? Those are going to show up in this black with the red text. You can create your own coloring rules. When you do that, very similar to creating the display filters, you give it a name over here on the right, like my coloring rule. And then over here, oh, sorry, I got my left and rights. I don't know my alphabet. I don't know my left and rights. That's okay, because I mostly know Wireshark. We got our filters on the right, so we can, filter and say, hey, let's color everything that's SSH. And that has the TCP sequence equal to 1 with this coloring rule. Okay, so we have the coloring rule in there, but how do we tell it what colors to use? That's down here at the bottom, which to me is a little bit unintuitive, but it's okay, it works. So as I click on these different rules, see how those buttons, foreground and background, are changing colors? They're indicating the colors of your foreground coloring and background coloring that are being applied for that rule. So when I click on this new rule that we added, we can change the foreground text, right? Instead of being black, we could say, actually, we'll probably leave the foreground as black. That's good enough. And we'll make the background something that's going to be a little more stand out, right? So we'll do like a bright green background. Okay. Okay. And now those packets that match that coloring rule are going to stand out. What that coloring rule was showing me is the start of my SSH connections, right? Because that sequence number was set to 1, the relative sequence number, which would always be the first bytes of the packet being sent. And so now I can still see my big picture. Like here, let's filter down just to SSH. But within that, I can see, oh, there's a new connection. Oh, there's a new connection. Oh, there's a new connection. Right? And so we can still get the bigger picture of what's going on, but also have details that we want to see stand out to us. Okay? I didn't put that rule in a very good place, probably, because I put it above all the errors and stuff, and we'd probably actually want to see the errors first, rather than the fact that this is the first packet in a connection. You can always go back and update it. Where's my view coloring rules? And just, I think it's drag and drop. Yep, so we can drag it down and say, oh, let's go after these errors before those other things, right? Okay, I think I'm close to out of time. I could stand up here and talk about Wireshark forever. If you have questions, feel free to talk to me. I'll be here the rest of the conference. I've got some mini badges for Weber State if you want to come get a Weber State mini badge, right? Any final questions before we wrap up? Okay, well, thanks for being here. Thanks for your time.